So with that, we can now move on to the 3 variable K-map method. Okay, how do you do 3 variables? Maybe K-map method. Okay, so now the point here is you must be a little careful about how you actually write these terms. So let us start with a very simple example. Maybe can I look at f of a, b and c. Okay, f of a, b, c. A is the MSB and I am saying this is going to be what shall I say? Shall I consider so I will say the following. Okay, let me take a slightly complicated example. Okay, M1, M2, okay, M1, M2, M3 is not there, and then I am going to say M4, no, I will do M5, M6. Okay, so this is the expression that we want to simplify. Okay, so let us first, since it's the first example for the 3 variable case, we should write the truth table and take a look at it, right? This is F 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. Yeah, okay, and what is F? M1, M2, these are zeros, M4 is 0, M5, M6 and 0. Okay, so we want to simplify this expression. You can actually write out the terms for yourself and see what you get, by the way. Okay, I would urge you to please do the Boolean simplification independently first so that you can verify your answer. Again, it's very important. You have to do this in multiple methods and make sure that your answer is correct. Okay. So let's look at this particular case. How do we even extend the idea, right? We drew a K-map, right? We drew a K-map for the 2 variable case, which is basically here. How do we extend this for a 3 variable case, right? So now I will just do what is most logical. Okay, I am going to say I will iterate on A along the columns, right, along the rows, sorry, and then I will iterate on the combination of B and C along the rows. Okay, so let's see what we get here. I am going to do the following, right. So now when I have 2 variables, remember I have to do 4 combinations. So B bar, C bar, which corresponds to 0, 0 combination, B bar C, which is the 0, 1 combination, B C bar and then B C. Okay. So let us first write it like that and see what happens. B bar, C bar. Let me divide this into 4 first so that I okay, this is B bar C. Let me just write it like this to start with. Let's see what happens. A bar A, right. So I am iterating on A along the rows, along the columns I am iterating on B and C, combination of B and C, right. So what does this correspond to? 0, 1, 2, 3, okay, and then we are looking at A, B bar, C bar, right, which is basically 4, 5, 6 and 7. Okay. Now the question really is this the correct representation? Okay. So let's go ahead and see what we get first. Let's populate this truth table. Okay. So you get 0, there is M1, M2, right? So M1, M2 and then M5, M6, correct? Yeah, this is basically what you get. Okay. Now I can actually do two things, right? I can actually simply group either these two terms, right? So you look at this, I can actually group these two terms, right? And then I can group these also, right? But the real question is this even correct? Okay, is this even correct what we have done here? What does this even mean, right? What the representation of the the K map is not wrong. We have just said 0, 1, 2, 3, 4, 5, 6, 7. But when we go ahead and circle terms like this and try to do exactly what we did in the two variable case, we have to be a little careful. Okay. So let us understand what this actually means. Okay. When we say we want to do this, it means that A bar is same. Amongst these two terms, if you look at what remains constant, right? Actually, there is nothing that remains constant. B bar C, B C bar. This is like our XOR case that we were talking about, right? So, how can I circle two terms like this? How can I even circle two terms like this and get that to work, right? What does it even mean, right? So, for example, M1 is A bar, B bar, C, and M2 is A bar, B, C bar. Okay. What we are saying is M1 or M2 is A bar, B bar, C plus A, B, C bar. I mean A bar, yeah. So, at most you can say this is A bar into B bar C plus B, C bar, right? A bar does not go out, okay? Neither does B or C go out of this expression. So, when you group these two terms, remember when we did this circling and we said the magenta here, right? The whole idea was the variable B got eliminated from that Boolean literal and therefore this expression simplified. But you cannot be doing this circling here because B is changing, C is also changing when you go from 1 to 2, 5 to 6. Okay, and therefore you cannot be grouping terms like this or even representing the K map for a 3 variable case in this manner. Okay. So, for that we will discuss what is known as the Gray code first. Okay. What is a Gray code, and or before that, what is it that we wanted here when we were going, right? When you go from one box of this K map to the neighboring box, we expect that only one variable has changed, or only one variable has changed in the process, and thereby you can group that two ones and eliminate a variable from that. The changed variable, it means the output is not a function of that changing variable, right? Because there are only two states, 0 and 1, it doesn't depend on either, and therefore you can eliminate that variable from the final expression. That's the idea. So what you need is a representation of this whole K map where when you go from one box to the other box, you have only one variable that is changing, whether you go along the x direction or along the y direction, only one variable should change. Okay, that's the whole idea. So the Gray code is basically a code which is going to ensure that you have only one variable that changes from one line to the next line. So let us look at that. I am going to write the decimal 0, 1, 2, 3, 4, 5, 6, 7. Okay, and then I am going to write the binary representation first. Binary representation, and then I will write the gray code. Okay, binary is 0, 0, 0. Okay, of course I am talking of 3 variables here: 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right? So clearly, when you go from here to here, this is the case we saw earlier. You have the lower 2 bits, right? Maybe I will also just move everything down so that I can write the. Okay, so let me write that. This is A, B, C. So when we go from, in this case, when we go from here to here, both B and C are changing, and therefore that's not good for us, right? Likewise, when you go from here to here, A, B, C, everything is changing. Okay, A 0 has to become 1, B the 1 has to become 0, C 1 has to become 0. So therefore this is also not a good thing. So what we want is a gray code representation which is like this. So we start with 0, 0, 0. Now you can toggle the state. What does toggling mean? Making this, the switch goes from on to off or off to on. So if it's a 0, you make it a 1, if it's a 1, you make it 0. So now you simply say, I will toggle C, the lowest bit. Yes, therefore only 1 bit has changed. Now I go ahead and say, can I toggle, if I toggle C again, I lose, I go back to the first state. Therefore that is useless. Therefore I will toggle B, but keep C the same, right? Now when I come here, I can now toggle C without affecting B. So this is what you get. Okay. Now the next thing that I can do, right? If you toggle C here again, you have a problem. You will go back 1 state. No use. So you got to toggle A. 1, 1, 0. Okay. And then now I can toggle C. It will become like this. Okay. After this, I can again start toggling. Now what should I do? Suppose I do, so if I toggle C after this, there is no use because I am going back 1 state. So I will toggle B. 1, 0, 1, 1, 0, 0. Okay, so if you look at the decimal representation, the binary representation of this gray code, it's going to look like this: 0, 1, 3, 2, 4, no, 6, 7, 5, 4. Right? Effectively, this is what we have. Okay. Now we will see how we can take this idea of the gray code into the K-map. Okay. So we are going to now look at, so I told you that, remember, the rule is very simple. When you go from one cell of the K-map to the next cell, either in the X direction or the Y direction, only 1 bit should change. Only then you will be able to group terms and simplify. Okay. So therefore, let's go ahead and try this. A, B, C. Okay. So I have the 0, 1. So the idea is now to go like this: 0, 1, 3, 2. Okay. and then what do I have? From 2 I want to go to 6. So when I go from 2 to the next cell, it has to be 6. Okay, because 2 to 6 only one bit is changing. And then I come back this way, 7, 5, 4. Okay. So now you can actually, you check, for example, for 3 and 7. What is 3? It is 0, 1, 1. What is 7? 1, 1, 1. Only one bit has changed. Okay. Likewise, you check this case, 1 and 5. Here, what is 1? 0, 0, 1. 5, 1, 0, 1. Okay. Likewise, 0 and 4. 0 is 0, 0, 0. 4 is simply 1, 0, 0. Therefore, in both cases, only these two bits have changed, and therefore you are perfectly fine. So, in fact, it is only the MSB that will change when you go vertically, right? So, this is now B bar, C bar, then you do B bar, C. Then you write BC. So, going from BC bar to BC, only C has changed. B has remained the same. BC bar. Okay. Effectively, this is what we have now. Now, why is it okay to reorder these, these numbers like this and represent in the gray code and group it, right? Remember, ultimately, we are saying that the f of A, comma B, comma C is M1 plus M2 plus M5 plus M6. All we are saying is, because this is an OR condition, it is commutative. You can do it in any order. You can do it as M1 plus M5 and do M2 plus M6, or in any order that you want, right? That's what this permutation here that we have done, right? We have just said, write it as 0, 1, 3, 2, 4, 5, 7, 6. Right. So, you going from one cell to the other, only one bit has changed. Now you can group terms happily and then get away with very simple, with a very, very simple solution to the problem. So, let's go ahead and now solve the same problem, M1, okay, M1, M2, then there is M5 and M6. Okay. Now it makes sense, okay, for us to go ahead and do this grouping, this one and this one. Okay. So, what does this mean now? F of A, B, C, right? Clearly, this is A bar and A, I am sorry. Yeah, not, A bar and A. Clearly, going from M1 to M5, A bar is out of the equation. It does not seem to depend on A, right? And therefore, this is simply going to be BC bar, or, okay, I'll color code it correctly, BC bar, okay, or similarly for the B bar C term. Okay, and therefore you are able to simplify this very, very nicely. Okay. Now, the important thing to notice is that you can group terms like this, and you can also do more interesting things in the 3 variable case. So, let us now switch to another example. Okay. I am going to say f of A, B and C is going to be summation M1, M3, M1, M2, M3, M7. Okay. By the way, alternately, this can also be written in some textbooks as this 1, 2, 3 and 7. Okay. See, because you are talking of sum of products, right? This means that this has to be a min term. It has to be small m1, m2, m3, m7. It cannot be capital this thing, right? If you write the product, then you know that has to be a max term. So therefore, that small m, capital M can be removed. It's just a redundant representation that we are using. Okay, so let's go ahead and try to simplify this expression and see what we get. Okay. Again, we are assuming A is the MSB here. Okay. BC, A. Okay, so I am going to write 0, 1, 3, 2, 4, 5, 7, 6, right. This is A bar, A, B bar, C bar, B bar, C, BC and then BC whole bar. Okay. So, what do I have? I have M 1, 2. No, I didn't want that. Sorry. What did I want? I'm going to change this function. I'm going to say this is 1, 3, 5, 7. Okay. So, what do we have? 1, 1, 1, 1. Right. Now, we know that we can group two terms. Right. So, we can now group like this. You will get one term. Then you can group like this. You will get the other term. But I also told you that you can add as many, you can repeat as many min terms as you want and you will not alter the Boolean function, right. So therefore, if I go ahead and start adding, this M3, M1, M3 terms, if I add more of them, I can also group like this and then I can group like this, right. So effectively, I can do that. So what it basically means is, you can even group in sets of 4. In sets of 4, okay. F of A, B, C basically means that you just look at the set of 4, going along the y direction, the A is changing, therefore you can leave that out. Going along the x direction, B is changing and therefore you can leave that also out. The answer is simply C. Okay. This, if you want to verify, I urge you to try this. Suppose we do it like this. Okay, I am going to do these two terms. I am going to group like this. We will see what we get. Okay. So, F of A, B, C is going to be B bar C. Okay, A is changing. So, the red term is going to be B bar C. Okay, plus the orange term is going to be BC. Now what do? You take C out, right, and then write this as B bar plus B, and therefore you can write this as C, right. That is what we are doing here by saying you are allowed to group even in sets of 4 if you wish. Okay. Now we will look at one more example to understand how we can operate on this 3 variable K map. Okay, F of A, B, C, I am going to say this is equal to, let me just go back, 0, 2, 4, 6, M0, M2, M4, M6. Okay. Now, again let me redraw the K map. A, B, C, zero, 1, 3, 2, 4, 5, 7, 6, right? And then I have B bar, C bar, B bar, C, B, C, B, C bar, okay, and then A bar and A. So what are we saying here? The K map is M0, 2, 4, 6, okay. This again seems to suggest to us that you can do two groupings like this, okay. This is what it suggests. So the F of A, B, C is simply going to be, no, I'll put this in magenta so that, okay, B bar, C bar in blue, B bar, C bar, and the magenta term is going to be B, C bar. Now what do? You take C bar out and therefore this reduces to C bar into B plus B bar. So what this means is the grouping of the four terms can also be done across the corners. So if you look at this B bar, C bar, B, C bar, right, clearly only one term is changing, right? It's only B that is changing, C bar is constant across that. So therefore the way you will group this is like this. Right, so it is like sort of a circular thing. You are rolling over and then grouping across that boundary, okay, and therefore the answer here is across these four terms A bar is changing, then you look at B bar is changing, right, B bar is becoming B, and therefore the final answer is simply going to be F of A, B, C equal to C bar. Right. So what that basically means is we have a lot of freedom to do grouping in terms of four terms, four literals, four min terms, and simplify the expression in a very, very effective and efficient way, right.